Once upon a time, there was a beautiful, smart, strong, flexible SQL statement named select. Select could analyze data brilliantly. It filtered rows easily. It could aggregate various, it could aggregate various data sets in various ways. It aggregated data nicely. It could even analyze moving windows of data in a really clever way. But that wasn't enough. It wanted more. There was one thing that Select wanted to do, but couldn't do well: finding patterns in row sequences. Well, it could do it, but usually these queries were cumbersome and non-elegant, and many times suffered from poor performance. Until one day, the select statement got a wonderful extension. In version 12.1, it got the match recognize clause. Match recognize allows us to perform enhanced analysis of row sequences and to detect sequences that match complex patterns. It gave a significant boost to the analytical capabilities of SQL. It allows to solve various types of problems in a simpler way than before, in more elegant way than before, and many times in much better performance than before. It is very powerful, and as you know, with great power comes complex syntax. And this complex syntax intimidates many developers. And I think it's pity because, in my opinion, match recognize should be in the toolbox of every Oracle developer. So the purpose of this session is to start using pattern matching. And we'll do it in small bites, step by step, so you can see that this monster is actually quite cute. And more importantly, useful. We will not cover all the capabilities of match recognize. It's impossible in 45 minutes, but we will cover quite a lot, and we'll do it only with simple examples. And at the end, if you want to know more, I'll give you some recommended links. My name is Oren Nakdimon. I'm an Oracle ACE director from Israel. I am an Oracle developer for 26 years now. I work for MoveIt, where I'm responsible for the database development. And I use the nickname DB-oriented for my activity in the Oracle users community. I tweet about Oracle stuff. You're welcome to follow DB-oriented. And I write about Oracle and databases in my blog. I have some bookmarks here. You know bookmarks? You read books. So bookmarks with my blog address. You are welcome to take them. Visit the blog, download presentations, including this one, and read about Oracle stuff that I find interesting, and I hope that you will too. I'd like to give you one real-life example where I found match recognize really useful in my work at MoveIt. MoveIt is an application for public transportation, and one of the basic features is showing all the departure times of a specific line, bus line, train line, underground, ferry, any means of public transportation. But if there are many departures for the same line in the same day, this list becomes quite long. And we wanted an alternative view, which is frequency-based ranges. So here is the same data in a new view, and this conversion from concrete departure times to frequency-based ranges is done by a SQL query that uses match recognize for detecting both the ranges and the frequencies. And I think it's really cool, but I will not bore you with my work today. Today we'll do something else. We are going to analyze the winners of the Eurovision Song Contest. You know that the last contest was 2 weeks ago? You know where it was? in Israel. Because last year, this one. So I have a table with a row for every year of the contest since the first contest in 1956 until the last one 2 weeks ago. So we have a row for every year. We have the winning country, the song, the performer, points, language, and the host country. So, are you willing to analyze the Eurovision? Yes, I'll do it by myself. Okay, let's start with something very special, something very simple. Let's find all the wins of Luxembourg. Any idea how we'll write this query? I'll help you. It starts with select star from table and where winner equals Luxembourg, right? This is the obvious solution, right? But it is too easy. Let's do it with pattern matching. And now don't get me wrong. I don't say that pattern matching is the best solution for this question. It's not. It's probably a silly one, but it is a great, simple example to start with, and very soon we'll extend it to some queries that match recognize really make sense for. So, to understand the concept of pattern matching, let's imagine that we have a special indicator, Lux, for Luxembourg. We mark every record that its winner is Luxembourg as a Lux record. So 1960 is not a Lux record, but 1961 is a Lux record. No. Yes, 1965 is a Lux record, and so on. And now we are looking for a pattern based on the Lux indicator. And in this case, the pattern is very, very simple. We simply look for a Lux record. So here is a Lux record because we marked it, and this one, and this one, and this one. In pattern matching in SQL, the Lux indicator is called the pattern variable. Let's write the query. We select from the table, and we add the match recognize clause. We define the pattern, Lux, using a Boolean condition. In this case, winner equals Luxembourg. And we define the pattern itself, and as I said, a very simple pattern, we're looking for a Lux. And let's add all rows per match, and I'll elaborate about it later. So this is our first match, second match, and so on. And this is the result of the query. Okay? Simple? Simple. Let's change it just a bit. Now we want to find two successive wins of Luxembourg. Now think of the obvious solution for the first question. It's not helpful, right? We have to write something else. But the pattern matching solution needs only a tiny change to solve this question. This is the type of questions that pattern matching was born to solve. So, we use the same pattern variable, Lux, because we are looking for wins of Luxembourg. And here, because we are looking for successive records, we need to define the order. And in this case, we are looking for successive records with respect to the year column, right? So we can and should add order by to match recognize, order by year. And actually, if there is a match recognize query that doesn't specify order by, then most probably it is a bug, because it rarely makes sense to look for sequences in rows without defining the order of the sequence. And we change the pattern, and this is all we have to do. We are now looking for Lux. This is called pattern concatenation. We are looking for a Lux record followed by a Lux record. And this is our match. Okay, 1972, 1973, we have two successive wins of Luxembourg. Now, what about these two records? This is something very important to understand. We've seen that the pattern depends on the variables, but the variables also depend on the pattern. So these two records, I lied by marking them. They cannot be Lux because the pattern requires two successive Lux records. So they are not Lux and they actually have never been Lux. The marking, the classifying is done when the match is found. Okay? Now, what if, okay, this is the result. What if we wanted 3 successive wins or 17 successive wins? Repeating, concatenating the same pattern is not very nice, so we have a shortcut. Instead of Lux Lux, we can write Lux and 2 in curly brackets, and we'll get the same result. And this is called pattern quantifier. And there are many types of quantifiers. Not many, but several. We've seen this one. X means 1. Xn means exactly n consecutive occurrences of x. We can use this syntax for at least n consecutive occurrences of x. This one for any number between n and m. And this one for at most m occurrences of x. And there are even shorter shortcuts, and these ones are really popular. X star means 0 or more. X question mark means 0 or 1. And X plus means 1 or more consecutive occurrences of X. Which we know from, probably most of you know what does it remind you? Regular expression, right? This is a subset of the regular expression. So let's now find 1 or more successive wins of Luxembourg. Which quantifier should we use? 1 or more? You were not listening. Plus. So this is the only change. The pattern now is Lux plus 1 or more Lux records. So this is a match with 1 record, this is another match with 1 record, and this is a match with 2 successive records. And this is the output. Now let's compare the first query and the last one. When we use the pattern Lux, which means exactly 1 win of Luxembourg, we got these results. When we used Lux plus, which means 1 or more, we got these results. These are exactly the same results, right? But there is a major difference here, because in pattern matching, we are not looking only for records. We are looking for matches. And a match, each match is a consecutive sequence of rows that matches a specific pattern. So if it's all about matches, can we see the matches? Of course we can. We can add to the output of match recognize another columns, another expressions. We do it using the keyword measures, and one of the special functions that we can add to as a measure is match number. Let's add it also to the select list and execute. And now we can clearly see the difference. In the first query, we got 5 matches, each one with a single record, and in the second query, we got 4 matches, because match number 3 contains 1972 and 1973. Okay? Okay. I think I talked enough about Luxembourg, but after all, they won 5 times the Eurovision, and I'm sure you want to hear a sample of one of the winners. So I can drink. Match recognizes an operator in the SQL engine. It gets as input a record set, and it produces another record set as output. But what exactly are the input and the output? Many times there is a confusion, and people think that this is the input for match recognize, but it is not. The input is the table name that comes right before the match recognize keyword. And the output is this. And we can give an alias to the whole thing and use it in the select list. Now, it doesn't have to be just a table name, which means all the columns of all the records of the table. It can be a subquery simply by using an inline view. So for the next example, let's use only the years between 1990 and 2000 and these columns as the input for match recognize. So this is the actual input record set to the next example. Now, until now, we've seen only a single variable in every query. Obviously, we can define multiple pattern variables. So let's give an example, a silly example. Order by measure like before, all rows per match. I'll talk about it later. And let's define 3 pattern variables. I, which means that the winner starts with a capital I. LN for long name, when the song name is long. And UK, when the host country is UK. The question marks represent potential records for every variable. Why only potential? Because we don't know the pattern yet. So 1991, for example, Sweden starts with an S, so clearly it will not be an I record. 1990 can be an I, but until we know the pattern, we don't know if it is an I or not. So let's define a pattern. The pattern is I, LN, UK question mark. We are looking for an I record followed by LN, optionally followed by a UK. Okay, UK question marks 0 or 1. So this is an I record followed by an LN because the song name is long. And we don't have a UK to follow, but it is okay because the pattern said UK question mark. So this is our first match. 1992 could be an I, but the next record is not an LN. Okay, the song name is too short, so it is not an I record. Here is another match, I followed by LN, and here is a third match. In this case, we have I, LN, and UK. Okay, all of the 3 are valid results. Let's execute it, and we go to the result. Now, until now, all the pattern variables that we defined are independent of each other. There is the pattern that has the dependency, but each variable is independent of the others, and usually we like to do some dependency between variables, because looking for winner equals Luxembourg is not very interesting. A more interesting question can be like this one. Find 2 or more successive wins of the same country. I don't know which country. I want the query to find it for me. I expect it to find these 2 successive wins of Israel and these 3 of Ireland, but I don't know it. I want the query to find it. So let's define it. Select from table, match recognize, the standard stuff. And now the pattern. We are looking for some X record followed by 1 or more same records. And I define same as a record that its winner equals to the winner of the previous record in the input. Prev and next are special functions that allow us to look at records to look at values from previous and next records in the ordered input. Okay? What about X? I didn't define it. And the reason I didn't define it is that every record can be an X as long as it is followed by a same record. So I don't have to define it explicitly, and it is defined implicitly as always true. So all these records potentially can be an X. They are not, because they are not followed by same record until we reach 1992. It is followed by two same records, so it is an X. Okay? Let's execute, and we got the result. So now all of us know that it happened 3 times in the history of the Eurovision that a country won 2 or more times in a row. Let's make it more interesting. Let's find returning winners after break. For example, Luxembourg won in 72-73, and then other countries won until it made a comeback in 1983. Okay, so we're looking for such pattern. I'll use only the years between 71 and 91 just to make the output easier to read. Order by year, we want to see the match number, all rows per match, and we define the pattern. We start with some A record, followed by 0 or more same records. This is like before, because I want all the successive wins to be together. Okay, so winner equals prev winner. Now, we want at least one or more, different country. And they may be various countries, but all of them should be different than the country of the A record. So see how we do it. We define that the winner is not equal to A dot winner. We qualify the winner by A, which is a variable, which means let's look at the current match on the record that we marked as A. Okay, so Diff is winner not equal to A dot winner. And then finally, we want at least one like first. And like first is defined as winner equals A dot winner. Okay, are you with me? And we got 2 matches. Now, Match Recognize has some nice capabilities that help us to debug our work. One of them is the classifier function. Classifier shows us for every record in a match to which variable it was matched. Okay, so we can see clearly for every record if it is an A record, same, Diff, or like first. It is very helpful to see that we get what we meant to get. And the second capability is all rows per match with unmatched rows, which gives us all the matched rows as before, but in addition, we got also rows that are not part of any match. So in our example, now we get also Monaco, and we can see that the match number and the classifier are null, because Monaco is not part of any match. So we got this match for Luxembourg as a returning winner, and this one for Sweden as a returning winner. But if we look closer, we can see that Sweden was a returning winner even before. And United Kingdom was a returning winner, and Ireland as well. So why didn't we get these matches in the output? Because by default, when Oracle finds a match, it starts looking for the next match right after the first match. So if the first match ended in 1983, we'll start looking for the next one in 1984. It does not go back by default. We can change this default. We do it using a clause that is called after match skip. And the default is past last row. This is what we de facto used. The other options are to next row. So start looking at the second record from the previous match. And we have the options to first or to last variable, to the first occurrence or the last occurrence of a specific variable in the match. So in our case, we'd like to start looking where? Yeah, right, Sweden. Or, in other words, the first Diff record, right? Okay, so let's change it to first Diff. And now we get all the matches that we didn't get earlier, right? Luxembourg, Sweden from 1974, United Kingdom from 1976. Now, note that if we use the non-default option, then we may get the same record in different matches. And it may be in different roles. Like 1976 here, in the first match it is a Diff record, in the second match it is a Diff record as well, and in the third match it is an A record, which is a non-regular, something that we don't really use to in Select. Speaking of 1976, the winning song was a really cute one, so I'm sure you want to see a sample of it, but I must warn you, because it may be hard to watch because of the choreography. I can watch it all day long. That's nice, but it may be too much information for me. I may want to get, for every case of a winning winner, a returning winner, just the winner, the first and last years, and, for example, the number of years in between where other countries won. I can do it. It's basically the same query. There is one major difference. Here it is at last. Instead of all rows per match, one row per match. And this is very similar to group by. We want to aggregate all the records in one group, or in this case in one match, to a single record. And like in group by, we need to define the aggregates. And we do it in the measures key, the measures clause. So we want the winner, so we're taking the winner from the A record. Actually, if we had several A records in the match, it means the last one. In our case, there is always only one A record. We want the first year and the last year, and we use special functions. First and the last return the first and last value from the current match. Unlike prev and next that we've seen before, prev and next are for physical navigation. They look across matches. They look only at the row input row set. And first and last are for navigation in a specific match, in the context of the match. And we can use aggregate functions, but only these 5, and we cannot use distinct. And note that the aggregation here is only on the rows in the current match. And there is a nice capability here. We can look if we want on specific variable. So you see that now here we count only the diff.star, which means only the variables only the records that were mapped to the diff variable. So this is the non-winner years. Okay? Add it to the select list, execute, and we got 5 rows. Let's add another measure. I want the average points of the winner. Now take a look at this. If I wanted the average points of the other winners, not our winner, it is simple, right? Because all of them are classified as diff. So it's just average of diff.points. But the winner is mapped to A, optionally same, and like first. So I cannot just apply an aggregate function on it. But I can define a super variable using the subset keyword. I define W as the union of A, same, and like first. And once I did this, I can simply apply average on W.points, and I get the average points of the winner. Okay? Okay, enough with the Eurovision. But before that, has Latvia won ever the Eurovision? How many times? One time. When was it?
2003.
Close. 2002.
I wanna be the sunshine in your arms. I wanna be the light from the shooting stars. I wanna be the queen in your sweet lights. I wanna be the last spark in your eyes. I wanna be...
Okay, thank you. Let's go to some serious stuff like Fibonacci numbers. Let's find all the Fibonacci numbers between 1 and 100 using pattern matching. Once again, not the best choice to use pattern matching for finding Fibonacci numbers, but first, it is fun. And second, it allows me to show you another 4 capabilities of match recognize. So our input is all the numbers between 1 and 100. I call them X. Order by X, obviously, all rows per match. And now let's define. I want to define each Fibonacci number as an F for Fibonacci. So let's define the variable F. If X equals 1, it is a Fibonacci number, right? If X equals 2, it is a Fibonacci number. And if X equals to the last F before the current record, and the next to last, it is also a Fibonacci number. Now, we've seen last before, but this is an extended syntax of last. First of all, we say that we don't want every record in the match. We are looking only on records that are marked as F, right? We want the last Fibonacci number before the current record. So this is F. And then we define the offset. 1 record before the current row, or 2 F records before the current row. And finally, we say what we want to get from these records, the X column. So 3, for example, is an F because the last F before it was 2, and the next to last was 1. 3 equals 2 plus 1. And 4 is not a Fibonacci because the last F before it was 3, and the next to last was 2. And 5 is a Fibonacci for the same reason, right? And so on. And now to the tricky part. Last refers only to records in the current match. And the match is a consecutive sequence of records. So if we want 13 to be in the same match as 8 and 5, it means that all the records in between must be in the same match as well. But they are not F, right? They have to be something else. Let's say NF, not Fibonacci. So actually we are looking now for a single match that contains all the records, and each record is marked either as an F or an NF. And we do it using pattern alternation. F or NF, using pipe for or. And the order is important. If the record can be classified as an F, it will be an F. Only if not, it will be NF. And because we want all the numbers in the match, then we need to use the plus quantifier, one or more, and we want to apply it on the output of the alternation. So we are using grouping simply by wrapping it with parentheses. Okay? I take it as a yes. Let's add also the classifier so we can see in the match which is F and which is NF, and we got the result. But I'm still not happy because I got all the numbers and I wanted only the Fibonacci numbers. So we can use this cool syntax, which is called pattern exclusion. And this cool syntax means that NF is part of the match, but it is not part of the output. And that's it. And now I don't need the classifier anymore. And I got really what I wanted, Fibonacci numbers using pattern matching. And if you want to write more about it, the documentation is very good. We can't say it on every feature of Oracle, but the documentation of this feature, I think it's really good. And I guess, I don't know it is because of this guy, Keith Laker, which is the product manager for pattern matching. And he has a really good blog that talks also about pattern matching, not only about pattern matching, but there are many good posts there. And another blog is of Stu Ashton that investigated pattern matching very thoroughly and wrote a lot about it. And that's it. I guess our time is over, but I am here if you want to ask questions. Any questions? Thank you. I'm here afterwards.